water and irrigation efficiency it is defined in terms of both the size or the scale of the system, as well as the irrigation system performance, how uniform the water application is, and the response to the crop. I mean, how is the crop happy or not? You know, these are quantities that we kind of say how good a job are we doing, how efficient is our irrigation. I wanted to point this out. I don't know, no one's commented on my beautiful waving field of grass here. Yeah, you don't know how long it took me to make each one of those little blades of grass wiggle like that.
And you got
that was in the famine stage. That you had that.
Yeah. Yeah, that was famine.
From
Yeah.
eastern Colorado, right?
Yeah, eastern Colorado. I don't know where it is. It's but it's the
Just outside of Butte, right?
right, sure.
Near Whitehall, I guess.
Yeah.
It's always green.
Microsoft has a bunch of these, you know, backgrounds that they're movies. Okay, it's actually a movie. So I thought, oh, that would really be cool to have a, you know, waving field of grass there, and it only works in PowerPoint 2010. You know, so I had to find the computer that had the 2010 on it. Okay, so anyway, barriers, enough advertisements for Microsoft. I'm a stockholder, whatever. Barriers to irrigation efficiency and really quantifying, pinning down how efficient our irrigation is. It's hard to measure. Okay, we don't really. A lot of times we don't know how much water is going through the root zone and it's going back into the groundwater, and how much is, you know, a lot of times we don't know how much is running off. I mean, these are hard to measure. Uniformity. Now, if you know your crop, you go and buy a new pivot system or wheel line system, the pivot guy is going to know how to put what sprinklers to put on the system for your crop, and so you're probably going to have nice uniformity, but maybe not. Okay, and uniformity is a problem, and I've got a kind of a cool slide that shows that. We don't know, you know, how much where the groundwater is necessarily, and then the water that we do return to surface water or groundwater, we can use it for something else. Okay, so you know, all these things kind of make it tough to really see how efficient we are. Costs, like anything, the first cost is a huge barrier. Okay, and it just happens that the least expensive systems, okay, like flood irrigation, is cheap. You know, relatively cheap. So you can just flood the field. And by the way, it's not really a very good picture. I think this is rice. Okay, and rice has to be wet. Okay, really wet like that. So it's really not an appropriate picture for this, because I'm kind of showing that it's flood irrigation, but it's.
It might be a little misleading in terms of the uniformity of flood irrigation.
Yes, yeah, very uniform. But you know, basically, the most expensive systems, the more money that you put into the system, first cost, they're more efficient. Okay, so the pivots are more expensive, and I do have the drip tape picture, and we said we were going to ignore that stuff. I was really in a bind about that. It really blew me away. History, common practices. I mean, we were talking about experience trumping all scientific knowledge, it's like, this is working. Why should I mess with it? And also, of course, water rights we're talking about. If you make your irrigation system more efficient, are you going to get that much water again in the future? And so there's a lot of people are afraid that if they use less water, then they're not going to be able to show beneficial use, and so they're going to lose that quantity of water or some quantity of water, and no one wants to lose their water. Okay. So how, and you guys are super good at this stuff, I'm sure, estimating soil moisture levels. Normally we just feel it and look at it and get a sense of what it is, but nowadays they have sensors and gypsum blocks and things we can put in the soil and measure the soil moisture that way. This is a picture of a guy with his little, this is called a Paul Brown probe, getting a sample of dirt.
You guys have those, right?
We don't have one in our office.
If you wanted to buy a new, all ground soil moisture probe for the extension agents part of this project, Joel, I don't think you'd get turned down.
Okay.
We tried that with iPads last spring.
I think we should go for
It didn't
iPads.
fly.
I
Then you
have.
tried to shove your iPad in the ground?
Yeah.
Is there an app for
I
that?
was just going to say there's probably an app for that. Yeah, you just set the iPad on the ground and it not only tells you what kind of soil you have, sand. The iPad app says you've got sandy clay or sandy loam, and it's you've got 75% moisture content. So anyway, this is just a little slide from NRCS on
The squish test.
squish test. That's the scientific name for it? The squish test. Yeah.
You do that. You're at a producer's place. I'd like to perform a squish test.
Yeah, you go.
Use that back.
Go up to some of these old farmers and propose a squish test. And, yeah, it's going to really impress them. Whoops. So, okay, but and I probably should have put put a picture on of these sensors. Okay, but you guys know what the gypsum block sensors look like. Well, they're just literally little chunks of gypsum that are put in the soil at different depths, and they measure soil. There's probably a voltage difference across the soil block that's proportional somehow to the moisture level. So generally speaking, we put the sensors in at a couple different levels. Sometimes 6, I think commonly it's 6 inches, 12 inches, and 30 inches. So we can measure these, the soil moisture over time. So here's, these are days, and this is the soil moisture, and sometimes these things will have a field capacity line on them, so that's kind of the goal where we want to.
So are those somehow connected to the pivot itself or the system so that, because I thought I've heard of some recent technology where there are sensors scattered around the field that will actually, like the system will self-adjust, and those are based on soil and slope and all those things.
It can be done, yes. There's these, and a very bad slide later on is about instrumentation and telemetry. So yeah, you can get a system that will take the data from these kinds of soil moisture trending systems and put them onto your smartphone or laptop, computer, whatever. What I have seen is the farmer goes out and sees this, and when the moisture level is above the field capacity, he can shut the irrigation off. But much more common, they just leave it on.
I don't know if this is recent or not, but NRCS, at least in Gallatin County, they have a push for a new sensor program. And then you have to go buy the panel separately, and then I guess if you just invest a few thousand more dollars, then you can get the panel that hooks into that sensor system.
Mm-hmm. This one happens to be something called an AM 400. Is this familiar to you guys? There was an NCAT project about, it was probably about 11 years ago, called Montana Rivers Project, and this was what it was, where they would put in these AM 400 monitoring stations, and I think that the farmers still pretty much just left the irrigation system run, despite the added knowledge. This is a flooded field, by the way. This is not rice, it's corn. Yeah, if you, I mean, you can drown the crop, and I mean, you guys probably, I'm sure you've seen that. What, a couple of years ago, we had all kinds of flooding downstream on the Missouri, so we certainly had a lot of crop damage from that. And so what can we do about it? You know, if you are irrigating, you can shut off the irrigation, or you can increase drainage. This field happens to be in northern Colorado last spring. Or, you know, the cropping practices, you can pick a dryland crop. Maybe there's a more drought-resistant cultivar. These, and again, you guys are more plant-oriented than I am, but it's my impression that new cultivars are being developed all the time, and there's a big push for more drought-resistant cultivars. So, you know, kind of keep an eye out for these new cultivars that are out there that, you know, you might be able to grow and save some irrigation. Pick crops that are more efficient, and there's also some crop rotations that we can use to save water. For example, corn and sugar beets. I don't know how many corn and sugar beet farms there are in Montana, but I know that there's some. Quite a bit of sugar beets. I don't know about corn.
Billings area.
Yeah.
They're usually in rotation together.
These.
Around Billings and around Sydney.
Okay. Yeah. Other practices. These can all save some irrigation water, leaving things fallow, using cover crops, no-till, and mulches. And as I said at the beginning, that I tried to put the references on the bottom of each screen. So if you know, and really this is the value, to me, this is more valuable than the presentation itself is. If you think, okay, well, we're talking about this, where can I get more information? It's right there on the screen. So, so when you can go and get this where it's posted online and get those references. These are a couple of examples of bad uniformity. You know, this is not too bad, but you can see these unirrigated lines where the pivot has missed, the sprinklers has missed. So it's a, what's that called? Not a Freudian slip, but a pun, yeah. The sprinklers have missed. And this one is spoking, where the mover is not uniform, and so you get some growth, some high growth, and some places that aren't growing. You know, because
So are there a couple things that could be happening there on the one on the right? Like possibly plugged nozzles, but also your wind speed, and the speed of your mover. Would that cause that?
yeah,
I mean, because
I think
wind, I mean, if you have it on at a tenth of an inch, and you're moving around there, and the wind's blowing pretty hard, you're gonna miss a lot of crop.
Yeah, I think in this particular case, it's like a plugged sprinkler or something. It's maintenance issues. But yeah, wind is, with the new low pressure nozzles, and they drop them close to the crop, then that's to minimize wind drift. But like so many pictures of pivots, you can just see the wind is blowing the stuff off.
Well, I know the irrigation guys always try to sell these guys an end gun, but in our area, and an end gun's like pretty, they say, oh, you get an extra 10 acres or 20 acres. It doesn't seem to be very efficient at all.
It's not
It's
very
not
efficient.
even worth the money to put that on there.
Right, and the irrigation people, of course, they want to sell irrigation stuff, and that is something that they want to sell, those end guns. There's a couple of things that the end guns do that I think are a burden on the efficiency. One is that they don't apply the water very well to the ground. I mean, yeah, they get water there, so there is a lot of wind drift from them, and also those have a higher pressure requirement than the drop sprinklers. And so the pump, and it's way out on the end of the line. So you got a high flow and pressure requirement way out at the end of the lateral. And so that makes the pump work hard to serve that last sprinkler. So, yeah, I don't know.
So does that mess up the efficiency of your low flow nozzles because you're pushing a lot of volume as well as pressure? Or all those drop downs supposed to be the same?
Well, the drops are supposed to be the same pressure, and there's regulators if you have a problem with pressure, but the end gun is going to have a high pressure requirement. So yeah, I don't know how that is really going to reconcile between the end gun and the dropped sprinklers. I think that it's a conflict. Yeah. But they do, and the farmers do think that they help. So I mean, you do see them out there, and the farmer says, "Yeah, I had an end gun, 'cause I think I get a little bit more out of it, So everyone's kind of on the fence
But
about
I
that.
would think energy-wise, a little bit more
If you compare
If
the
you
cost to
compare
get the
the
water
cost
there versus.
Yeah, and
Drops.
there.
And I think I was reading, I can't remember what website it was, but I was reading about these end guns, and I think even the manufacturer's website said it may be worth it. I mean, it may be a benefit. They weren't saying, this is definitely a good deal. So, I don't know. Yeah, from the efficiency standpoint, I don't think I'm a fan. If I absolutely had to get every little piece of crop out of that, square, the problem with pivots, of course, is they're round and you've got a square piece of ground. So, if you got to get every piece of crop out of that square that you can, then maybe you go for it. But
Well, if
I
you've
don't
got
know
to
if
do
it's-
that, then you need to just move pipe in your corners.
yeah,
I
and
mean-
and there's all kinds of other ways to
Because
do it
that's-
too.
Guys who really need to do that, who need to make that work, will irrigate their pivot corners. But if they don't, then, they'll just plant a crested wheat or something to fill up that. So that
Yeah,
weeds
yeah.
In the corners. But
Well, and the thing is the design of the systems, which I'm not going to try to get into at all. There's all kinds of different ways to arrange the systems, and to fill in with a wheel line, or just a few hand line sprinklers, or and then there's different corner systems, and yeah, there's all kinds of different ways to do it. So there's do a full circle, and then partial circle, partial circle, partial circle to make a long, so there's all kinds of different arrangements of those things. And I think that there's some references that have all that stuff in them. So how do we get the water to the system? You said you got gravity feed, which is very nice. If you here's a pop quiz. If you've got 40 psi pivot, how high does the water have to be fed into the gravity system to get 40 psi? Is it? It's between 80 and 90 feet. So do you have 80 or 90 feet of fall into the gravity system?
Does the volume affect that?
No. No, it's just the water column. The weight of the water is what makes that pressure. So is it feeding a pivot?
No, it's not. Well, not at my place.
Yeah.
I can't afford a pivot. I have like 15 sticks of pipe.
Okay.
But yes, it does feed some pivots. I don't know how many in a whole bunch of wheel lines.
Yeah,
I
yeah.
mean, I think the pressure stays about 65
Oh,
all
okay.
the time. It comes down from Birch Creek.
Yeah.
How
So,
much drop do you have in your system?
yeah.
I don't know. I've never been up there at the head.
Yeah.
So
Well,
I'm
if
here
it's
to learn.
if it's the answer is 65 times 2.3 feet. Yeah. Has to be. Yeah, because a foot of water is 2.3 or
So you
2.
give us a white paper on your system, right? So we can
Oh,
all.
you're not going to
use
want me
you
to
as
have
a
my
case
cell
study.
phone. Sorry, I don't have a calculator, so.
I don't want to be the case study.
Bring the
Well,
flow meter
there's
down and see
probably
what you
there's
got.
probably a whole lot of other problems because the system was put in the 60s. So I mean, as far as like leaks and
Oh, yeah,
you know
yeah, yeah.
some degraded parts, wear and tear that. So it's probably not very efficient, I guess, is what I'm saying. Because you know when they replace a part, that part's new, but a whole bunch of other parts are not.
It sounds like the Butte municipal water system.
So
They'll put a piece of pipe here, and then next week there's a leak right here next
Right.
to it. Yeah.
So I'm sure it's not very efficient, and then everybody has leaks on their systems,
Mhm.
all the way along the
Yeah.
whole route. We're at the very end,
Well, that's
so we're
that's a barrier is low cost of the pumping. If you have very low cost pumping, which you have zero cost, then why are you fixing leaks? Yeah. So, yeah.
well. I would like it fixed because we have more water down at ours at the end.
There you go.
But
Right.
where, you know, and that's, I don't think it'll ever change, maybe not in my lifetime, but,
Leaks are huge. We probably spend more money pumping water into leaks than, almost anything else, especially in municipal systems. Municipal water systems are very leaky. So we spend in our cities, we use a lot of, the water systems are leaking. And so we don't see the leaks because they don't, a lot of times it will come up through the ground on the top of the ground, but sometimes it just goes into the groundwater. So every now and then you'll see guys out there with their stethoscopes. Have you ever seen a guy with a stethoscope listening for leaks? Yeah.
so how much loss are we actually having then, on any system? I mean, you don't have to be talking about the system I'm on, but when you don't have a plug in your 4 or 5 inch well line, because you know how the bottom of the well lines there's the drain plug,
Mhm.
but as you drive down the road you always see somebody who's missing a couple of them, and so the water's just fanning out.
Yeah.
It's pressuring up to the heads, but there's usually a big fan of water.
Yeah.
You know,
Yeah.
I mean,
Well,
are
there's,
they losing quite a bit.
it's,
due to
yeah,
that?
I'd say quite a
Because
bit.
It looks like.
Yeah, it looks like quite a bit.
but
Yeah, I'd say quite a bit. Yeah, that's the, when you do an energy audit of a water system, that's the first thing you do is you say, fix the leaks. That's the first thing you do. Yeah. So, yeah, that's you know, before you do any kind of other efficiency improvements, you fix leaks. Now, the utility considers fixing leaks maintenance. Okay, so when we talk about utility programs and cost share for efficiency improvements from the utilities, if you go to the utility and say, well, we're going to fix leaks and we're going to save this many kilowatt hours because we're fixing these many leaks, the utility says, well, we're not going to help pay for it because you should have been maintaining the system. So that's just another way to look at it. But yeah, that's the first thing you get is leaks. And you'll see signs or slides where I'm talking about recommendations. That's the first one. Pumping systems, of course, most common is electric powered, but we do have fueled pumping systems, and so we'll go into this stuff ad nauseum. Okay, delivery systems. We've been talking about flood irrigation, and this is a very nice picture of a canvas dam that is feeding a flood area, and then drip systems. I still have this, you know, unease about talking about drip systems, but I'm hopeful that this is the last item that we talk about drip systems. Hand lines, you guys have seen all these, I'm sure. And then wheel lines and pivots. Okay, so these are what we are talking about.